Hello, everyone. Welcome back to our workshop session. In this workshop, we are very happy to have Kasha Das, who is a Python core developer and also a director at the Python Software Foundation, to talk about the writing Python extension in Rust. So Kasha is, again, a Python Software Foundation director and also part of the project core team. One of the maintainer of Secure Drop and the author of various free software tools. He founded the Linux users group in Dugapu back in 2004 with the goal of helping people to becoming upstream contributors. And he also regularly blogs at the address that you can find out in the description. So, Kasha, maybe you can share the screen now.
Hello again. Yeah, before sharing screen, I just want to thank you and also welcome everyone. So today's session is going to be about two languages I love. Python is, of course, my first love in that case. And we're also going to use something new, that is Rust programming language. And we'll try to create Python modules using Rust. The whole session is going to be mostly hands-on. That means I hope that few of you will follow along, and everything is almost written down beforehand, so you don't have to write too much of new code. Even if you do not know Rust, I think you'll be able to follow along. I'll just jump to... I hope all of you will be able to see this screen. And I'll actually go back to Firefox. So this is the public repository on my GitHub, github.com kushaldas/randomos. So you can just clone the repository and start from there. And the very first two steps is the major step is installing Rust, following Rust up. And then we are going to create a virtual environment and install the dependencies. So I'll just first go through up to this and then start explaining a little bit more. As I said, I will start from a clean state. So I'm -rf, random OS, Control R, git clone. So git clone. Oops. And I already have Rust installed. I think this is the correct. Yep, Rusty 5.54 in this box. Now, okay, this is the big mistake I do, that I do not get into the screen. So here, I should remember to change between screens, Firefox and the terminal. So I just git cloned, as you can see on the top, the repository, CD, and then checking the Rusty version. Now, if I see a README file here, it talks about creating a virtual environment. We'll activate the virtual environment, then install the dependencies. So I'll just copy this command beforehand and try to follow along the steps. So first step would be creating a virtual environment. Then we'll activate it. Then we'll install the dependencies we need for this workshop. Done. And to verify that you have installed everything correctly, including Rust, we should type this command. And remember, right now for the main branch, this command will fail at the very end, but it will compile. There will be no compilation error for sure. So there is a warning. So you should be able to see this warning. And I will wait here for all of you right now. And if anyone is following, and Stephen, if you can tell me if anyone has any question right at this step. I'll just wait and then we'll go along.
Yeah, so there seem to be no question yet, but feel free to type the questions. There might be a slight delay of around 30 seconds. So just type in the comment box and I'll bring it up.
Perfect. Thank you. So while people are trying it out, I'll go, what is this Maturin and what exactly we are going to do here. So as I said, we will be using Rust to create the Python extension instead of C. Maybe your first question is why? Why not just write it in C? There are many different answers to that. One of the easiest ways to explain is that if you use Rust, you will get all the benefits of Rust as a programming language and still can use it from the programming language you love or you want at that moment, that is Python. And that, in my mind, that's a perfect mix and match between two things. And obviously, the memory safety and all the other language features Rust provides, and also the speed. It's almost similar level to C, maybe not 100% C, but you'll find that it's almost fast enough for all of your need. Now, if I go back to Firefox, so the actual project which we are dependent on for today's workshop is called Pyo3. This is the project which helps us to write the extension in Rust, and then using a tool called Maturin, which is again developed by the same team, we can build the extension. So the website is pyo3.rs, and we're going to use this. If I go back, I hope there's still no questions, so I'll go back to the terminal and we'll start looking into things. Let's do ls. So for any Rust project, the primary file to start looking at is the cargo.pml. I hope I have the right cat extension. Yep. So this is the cargo.yml file, which is a standard file for any Rust project. I'm just saying the name is randomOS, which is in our case also, like below you can see is the module name. I'm saying we're dependent on Pyo3 14.5 and using the extensions module. And then I also wrote down a few Python packaging metadata. These will be consumed by the tool Maturin. It also includes project URL. Next big thing is the pyproject.yml. And here we are again saying using the Maturin version, which we are using, the build backend. And because I'll be, at the end of this particular demo, we'll be creating Python will, which is not many Linux compatible. So I'm just saying that many Linux is off. This means it will create a native operating system and architecture-based will. Now, to jump into the actual code, right now, if you see in Rust, the source code is always in the src directory. So if I see, then it has the default standard Rust example into the src/lib.rs. We're going to write all the source code here. So the first branch we should check out is called hello. Git checkout hello. I'm going to open up the same lib.rs. Or I can do it in Vim, I guess. That will be better. Okay. So we are saying that we're going to use the Pyo3 crate and some details from there. And I'm defining a function with the fn hello and just printing hello world. And before that, if we declare like this, it will be mentioned as a function inside the Python module or extension. And at the very end, we are actually defining the real module. Here is one thing to notice is that I still don't know why in my Vim setup along with Rust Analyzer, it always shows me an error, but not for the compilation part. I'm yet to find out why. But these
So it seems to have a problem. So someone is admin is getting a warning. So warning couldn't find the following symbol pi in each
correct.
random nodes,
Yeah.
and if he should be worried.
No, so you should get that if you are in the main branch. Because as I said, if you're in the main branch, there will be no such, there is no code written yet. So you should only get that warning. Please have a look on my screen. You will see the similar warning. I hope this answers your question. In the main branch, there is no actual code written yet. Stephen, please check it if this answers the question.
Yes, Edwin. So if this doesn't answer your question, you can follow up. Yeah, okay. It seems to be resolved.
Perfect. So if I go into the hello now, and now do matter in develop, you will see there's no error or warning in this case, because now it has the actual source code. Now, what happens when we type develop, that it builds the extension and puts in the right directory inside our virtual environment. So at this moment, we can import the module and try it out. See, now we could import a random OS module. And I think this is our function, random OS hello, hello world. It works. We did nothing fancy, but except just printing hello world. Please try it out. I'll wait, because if this works, that means you already managed to compile and use your own Python extension written in Rust. If you have any questions, please type it out so that we can answer. And because this is only 1.5 hours for this session, I will try to do as much as show you what all random things you can do using this. And for more technical details, you can always go back to the documentation of PyO3. Any questions? I guess not. So I will move along. The next branch we'll move is called hello underscore name. So now if I see the source code, we'll find there is slight change. Now we are accepting a variable called name as an argument here in the variable name. And we are also returning something called pi result as a string. So because this is Rust, we are actually, in Rust, we are using the format macro to create a string, which is in this case will be hello and whatever name we reply, specified. And that argument and then the variable answer, we are returning it as inside this OK call, so that it becomes a result object and it's going out in line number. Here, I'll just go up, line number 5 as pi result. So now from Python, we can actually call hello with an argument, and we'll also return, the function call will return us back a string. So we're going to try this out now. The first step to remember is matter in develop. So one of the very common problem with me while trying to use write regular Rust and Python modules is that I keep forgetting about recompiling my Rust code and then wondering why nothing changed in Python side. So you have to remember that too. So Python 3, import randomwise. And if I try to call hello now, it says it's missing one required positional argument, name. So I can type something like result equal to, let's say PyCon AC. Let's see what happens. Nothing. So no error at least. If I print result now, hello PyCon AC. It took our argument, it created a new string and returned it from Rust. So the string was created in Rust, but now we can access the answer in Python. Can you all please try this? And one quick question so that it will be easier for us and particularly for Stephen to follow up is that if you are typing alone, if you can just type in the chat box in the YouTube that you are following along so that we know how many people are actually trying out. That way I can decide like how fast we can go or like, slow or we'll wait so that all of us are in the same space. I'm almost thinking of opening up another tab in another computer in the browser and just open up the video to see if there is like anything. But then I'll get confused between two computers. I know for
Yeah,
sure.
we don't have anything
Good.
for now. I guess we can continue. And then we have a Helio saying I'm watching and I will try later.
Okay. So the next branch we'll move into is hello name underscore docs. You can imagine from the name is that we're going to now learn a little bit more about doc strings and documentation here. So there you go. We added two things. One major part is here with the three slashes is the doc string for the function. It says hello to the name given, returns a string. And we are also adding a text signature. This will help us for if you're using any kind of particular IDE and inside of that. So there's nothing else changed at this moment. So I will just compile again. Okay, something is deprecated in between. And I forgot to update my example. So it says now instead of this, use this PyO3 text signature. So this is another one of the very nice thing about Rust, which I love, and Python 3.10 actually is catching up a lot in that area, is that giving us much better error messages. So let's fix this for now. Let's just write it within a PyO3. Let's try if this works. I just did the change based on whatever the compiler told me. Perfect. Import random OS. Now if I do help on random os.hello, you can see hello name and says hello to the name given. This is the exact string which we wrote in our source code. If everyone is okay, I think I can just do a git diff to show you the change I made. So in the latest version of PyO3, we have to use this way so that the signatures come up properly without any deprecation warning. I'll not try to commit it. I'll just remove it from now and move along. So the next branch name is add_numbers. Now we are going to write a little bit more complex Rust code where we're going to add two numbers, complex, as I said. And this is the function where we are receiving two integers, a and b, and just returning back the sum of it, a plus b. So, and also I really thought I fixed this in all the branches. I think I missed it, the text signature part. So we will see some warnings, which I forgot to push maybe. Let me double check on another computer. Nope, I really forgot to write and push this. So yeah, we'll see some warnings because deprecation warnings in this case. But this is the new function we added. And here at the very end, if you notice, we just added that. I'll remove this first. In here, in this line, we added the function into the module m. And this is the syntax, which I just copy pasted from the example documentation. So same Turin develop. There will be two warnings, and I'm sorry for that, but I guess because I forgot to update this particular part, there'll be many more warnings. As you can see, it's just about the text signature attribute. Now, I also have some example code written out for this part of our like source code which we are trying. So you can see here that this is the code. We are importing random OS, adding two numbers, and then printing what is the answer. So what we can do is Python 3 or and this. The answer is 42. Is this good? If you have any queries, please feel free to ask. I'm trying to go slow so that if anyone is actually trying out along with us here, they can also follow up. No questions?
There seems to be no questions yet. I guess we can move on.
Yes. Sometimes no questions is kind of scary. This doesn't mean that everyone understood everything. It may be that it's going in a complete different direction. So what's the next branch? The next branch is read_file. Again, from the name you can understand now we are doing much more and more practical things. Even though we can read files, we know very easily in Python, but in this case, we read the file in Rust. The same source code. Here, the function read_file. We're taking a file name as a string, Then for opening the file name and throwing an like error message if the file is not there, then reading the whole file at one go, which is not may not be the right way of doing, but just because this is an example, we can do this. And please remember, try not to read a whole file and keep it, store it on memory, because depending on the like the environment your code is running, this may go really bad. And then returning the whole data as bytes. From like this is res is the Python pi bytes, which is the Python bytes in this case, and it will go back via the result object. So again, I'll wait for the compilation and more warnings. Sorry for that. And there is already an example in this called read_file.py. You can see import random OS, and because we are in our Git repository, I can try to read our git ignore file. So I'll just like interpreting that file, and I want to land into my interpreter. So I'll pass python3-i, and then the file name. Oops. At this moment, we already have the variable data, so I can print data. You can see it's a bytes, and it contains all the lines from our git ignore file. So if I go back to the source code, you will notice one thing, that we are taking these pi bytes, and then we are returning it back inside pi result, but instead of writing pi bytes, I wrote it here pi object. So to know more about like why we are doing this and how this conversation between Rust data types and Python works, PyO3 has a very nice table. So we'll try to have a look at it now. Let's go back to Firefox and type conversations. Here. So in this table, you will find out all the details, like if it is bytes in Python side, we may receive, like we will receive it as most probably either a vector of U8. And when we are returning back, we can return back bytes as pi bytes. And then for various other readily available Python object type, like the classes and the objects which we can send across. So please remember to consult the documentation. This is really nice. And the upstream developers are also very helpful. If you go to their GitHub channel and ask any questions, you'll find a lot of people asking various kinds of questions there. And if you are new to Python and like still don't know like whether it's a good idea or like if any of the projects are actually using it, you should always remember that the cryptography module, the standard Python cryptography module, is already using Rust code inside of it. So almost everything in the Python land in the whole world is somehow dependent on cryptography, I believe. And in that case, they're already using those part of the Rust code. I'll still go very slow because if there are any questions coming up. But we'll now learn also about exceptions. And I did not show this part on that in the last example, but yeah, we added much more use statements. So just to showcase that we are going to use more things from different crates, which is like if you're not from Rust world, crates are kind of Python modules which we can consume inside our code. And in this case, we are going to use this particular function called create exception. And here we are saying that there is a new exception in Python called small number error, which is part of this module and called its type of pi exception. And then we modified our add numbers. if the first argument a, if that is smaller than 10, it will throw that small number error and it will say that too small number. Okay, so if you remember the add numbers, it is adding two numbers a and b. So if the first argument is small, lesser than 10, it will throw this particular exception. So let's try this. I'll show you the code. excp.py, which is just random OS because we're going to type it out. So Python 3-i. The module is already imported, so we can now try add numbers. Let's say the first number is 4. The second number is 20. So the first argument is already lesser than 10. This means this should give us an exception. But I can tell you if I press enter right now, it will not give us any exception. If you can understand why. See, it just worked. If you remember, a few minutes ago, I told that while working on Rust and Python, one thing I keep forgetting again and again is that to recompile the code, which I did not in this case. So I should really recompile the code first and then go back and try the same example again. So now if I try to add two numbers, but the first argument is lesser than 10, you can see it throws small random OS dot small number error, too small number for think big. So now we are getting the exception, and now we can actually define our own exceptions inside the Rust and just use it in the same like any other normal exceptions in Python. You can see random OS dot double tab. You can see all the different things we already defined inside the module here. We crossed the half an hour mark. We have 1 hour and few bigger code examples, but once again, any questions? I'll wait and then go ahead. As a complete off-topic thing, today is also the first global encryption day. You should all check out the different events happening across the world. And I think right now there is another live discussion happening on YouTube. I think it's available on YouTube with Snowden and few more people about this. So check it out later on after this workshop, or maybe, yeah, I think this is the last workshop of the day. So any questions yet? Steven, do you know?
Yep, don't seem to be any. So if you have any questions, like just feel free to discuss. We will bring it up right away.
Yeah, you can interrupt me anytime, ask any kind of questions. May not have to be directly related to this. If you have any questions on Python land also, like feel free to ask. If I don't know, I can always tell you that I don't know, but whom to ask or where to find the answer. Meanwhile, we'll move into the next example. The branch name is called useless dict because we're going to create a dictionary and that's it. We'll just create a dictionary from Rust and we're going to use it. So there is not much going on here. But we will also see again how to create various Python objects, but from inside Rust itself. So here, the function hello now is modified. And here, so this example is, I thought I'm going to have another example of creating a dictionary. Now, I'm actually receiving a dictionary in this case. And in Rust, we use that data type hasMap represent like dictionary objects like in Python. And here we are saying the data, the argument is a type of hasMap, where both the key and value are both of type string. And then we are getting for the key name, the value of name and the city. And then I'm answering hello and welcome to name and city. So, and then returning back the result as a string. So here, cat examples, useless.py. I'm creating a dictionary in Python with the key name and the value is Kushal, city is NYC, and then calling hello with that Python dictionary and printing the answer. Let's try this. And we got an error. This is perfect. So it says dict object cannot be converted to PyString. And this is because the same error I did few minutes back. I did not recompile. As you can see, even if I'm trying to do this workshop, I'm missing this very simple step. And you can imagine why this is happening, because I still write more Python than Rust. And I'm not in, while writing Python code, I'm not into this habit of recompiling again and again. So here, now it works. Hello Kushal, welcome to NIC. I'll again stop and then try to see if you all can follow along. This is the new function which we wrote, where the data is of type Python dictionary, in this case, which comes into a hash map in Rust. The Pyo3 documentation, by the way, also contains various Python projects and modules which are using Pyo3. That means they wrote the code in Rust and then you are using it from Python. So if you cannot figure out some particular example, you can always go back and check those example modules which people like already other maintainers are maintaining, and then you can read those source code and try to understand and figure out how to do a certain thing which you want, exactly what you want to do. Generally, this particular workshop, when I did it before, it went above 2 hours because there were a lot of questions about people and people were getting much more number of mostly typing mistakes or like the same kind of errors which I'm getting, that is forgetting to recompile. So we're going a little bit fast right now than what I anticipated, but at the same time, I don't know if anyone is actually typing along, just watching the talk, which will also work. And I will obviously later on update my examples to make sure that every example contains the proper updated calls in Rust.
Yeah, so we have both people watching and typing along. So Jens is watching, is a video, and Edwin is typing along. And he said, "Is this going swimmingly?"
Means
So
it's perfect, correct?
working very well for him. Yes.
Okay, that's very good. Good to hear. So let's get into a little bit more bigger Python things. That is, we're going to write a class. The name of the branch is I underscore have a class, like with underscores in between. If I, where is the control? One more, maybe a little bit here. So here, we are declaring a structure and then also marking it to become a Python class. It's called rpath. It contains only one like attribute, original underscore path as a string. And then I'm implementing methods for this. Like these methods are, again, this will become a Python method, but in Rust, this is just a like function which we defined like this, called new. And we are saying that it will accept a string as an argument and return a object of the class rpath. And if you look at the very end, you can see that here we added, I'll just remove the line. Here we added the class into our module, our path. So first I should remember to compile this time. So Metadata develop. And you will see that there is a new warning right now, dead code, because we are not consuming this variable at all anywhere. But we'll see soon. Do I have an example? I think I do. Here, from the randomized module, we are now importing the rpath class and saying like give us an object of rpath with the variable dot/target as the value. So let's try this. Python 3-i in the file. Now, if we do R, it says it's a built-in rpath object. And if I do the dunder r double underscore and press double tap, you will notice something strange, that we still cannot see the internal attribute, that is the original underscore path here somewhere. So we cannot access it right now. So we'll try to see if we can modify the source code and access it somehow. Let's do this. Maybe original path. Let's try to see if I remember this correctly. Pio3. It should do. So we added a line saying Pio3 get and set. Now these methods will be automatically created inside the code, and we can access the original underscore path variable. So recompile before anything else. Okay, again, R is our object. So R dot, you can see now we have the original path value. I can also change it because set is also created. So I can say now we can actually access the attribute, and we can also set it if we want. If you are coming again from the Python background, you will remember the Python properties, and you will find some similarities here in this case. Is this good? I'll wait for a minute. I'm just checking my notes, what to talk about next. If no questions, I'm going ahead. If you have any queries, please ask in the channel, like YouTube chat, so that we can stop and try to find an answer. The next branch is ROS. Oh, I made some changes. I'll just reset. Git checkout ROS, and then go back to the source code. Here, in this particular branch, we are adding some functions which you can call and check inside our rpath class. And they are here, as you can see. The first function, you will notice that all of these exist for os.path module, but we are trying to now implement these as real life as possible in our Rust code, and try to see if we can do this. So we're checking whether the path provided exists or not, and it's returning a bool. And in the same way, we are also checking if the path is a directory or not, and what is the parent path. And then one more function to check whether, not function in this case, it's function in the Rust side, but in Python, it will be a method on the class, which will tell us whether this is a file or not. And after this, because again, from the name, as if we remember that we are adding like something, a new complete class, ROS, where we wrote something else, sysinfo system. So here we are going to use a complete separate Rust crate altogether, which will be compiled again inside our Python module, and will have some more advanced functionality. So in this particular case, we can see that we are finding out the number of processors we have on this system. Now, to make sure that this works, you will find that we also made some changes in our cargo.yml. Here, line number 15. So we are saying that we are not only dependent on PyO3, but we are also now dependent on the sysinfo crate. And using this crate, we will find out those information about the system. We'll go back on the source code so that we can still have a look at it again. Another small function, and we are just returning the number of processors from the sysinfo documentation as we read, and we are also adding, just like, oops, this is too many error messages showing up. Just like the rpath class, we are using the ROS class. So we'll try out both of these one by one. So to win develop. Okay, and you can notice that there are no warnings anymore. So I'll do Python 3 from random OS import rpath. Let's try this. R equal to rpath. We'll try the cargo.yml. And you can see the methods we defined, they already exist, like they are available here. So we can see whether the file exists or not. If I change it to tml2, you can see it returns false. Let's go back to the original file and then check if it is a directory. Nope, false. We can check if it is a file. True. And what is the parent directory in this case? Let's see what is the answer. Parent directory, because we provided not an absolute path, a relative path. I'll wait here before trying out or we can actually type the ROS part also. So from random OS import ROS, and now ROS equal to ROS. It gathered all the system information, and then if I do number of processors, it should tell us the number of processors you have. In this computer, I have 8 processors. Actually, number of cores, I believe, total 8, 4 processors. No, 4 core, 8 threads. That's the correct value. But please try this out. Please come over up to this this line so that we can go ahead and see more details, what's happening inside. Do you have any queries? If you have any queries, feel free to ask. Let's see if I have any documentation here. Only this. And one thing to notice here that it contains a dunder new method, but not a dunder in it. So you can actually read the PyO3 documentation and see this, like all of these classes will always have the dunder new, not dunder init inside of them when you will define a class in Rust. Also, one thing, if I now do ROS, it still says built-in ROS object, but maybe we can modify so that dunder str or dunder REPR, we can define those particular methods in a different way a little bit, so that when we type ROS in the terminal in the Python interpreter and press enter, you will get a better output. So I guess there are still no questions, so I'll go ahead. So what happens when we do this Matterine develop? Matterine actually compiles the whole source code and it creates a .so file in Linux. If I do file .venv library Python 3.7 site packages, I believe, and then oops, yep. Yep. So you can see it creates a .so file. If we execute the file command, you can see it will tell it's an ELF 64-bit. And when you type Matterine develop, it actually creates along with the debug info details. So this is good for our development environment. But when we want to give it out to someone else, we want a Python wheel. So for that, what we can do is execute a little bit different command, Matterine build. Notice it also created a source distribution. And you can see that it created a wheel for us, but the wheels also contains as a Linux tag, Linux, correct? It's not a many Linux wheel. This means you cannot push this wheel to the PyPI index, and there is a particular reason behind it. Also, one part is that we already told Matterine to not to use many Linux or not to try to build a many Linux compatible wheel. And also because if we do LDD on the same, the SO file, and 3.7 site packages, random OS, you'll find that this is compiled against and linked against multiple more libraries inside our system than it should be for a many Linux compatible wheel. But you can still create many Linux compatible wheels in your Rust code. I'm just showing this so that, if you get totally confused why, like if you're using certain type of Rust modules where you're linking against some system libraries written in C or C++ in or other languages, and then why can't you create a wheel which you can then upload to be used everywhere? Any questions so far?
Yes, so we have a question, but it's probably related to the previous case on exception. So I bring it up now. So Yan is asking, like, he's not sure why the question didn't show up earlier, but yeah, so YouTube is acting up. But the question is like, while all other examples work, he's getting a panic exception in the option unwrap. So I think this is for the case when the
Okay.
example with a dictionary.
Example with the dictionary?
Yes.
Okay, so I'll go back to that first. And because you are already getting a panic from the Rust code, this and in the option,
Yeah.
I think it's already means like you have to show us the example code. If you can post it somewhere.
It's when calling hello.
Yes. Uh, so here you're most probably getting the error because I'm calling this unwraps. The panic is from the Rust part where it stops, like the Rust side of the code, where you can actually, if I'm writing a proper Rust code, not a direct example, instead of calling it as unwrap, should check whether the name or the key name is there or not. The same with the key city. But instead, I'm hoping that both the name and the city are there. So please make sure that the dictionary you are passing along here in the data that contains both of these keys, name and city. Can you please double check?
Yeah. So Ian is also saying that it is still there in the last version of the code for him, even with rows, etc.
Okay, so can you just double check whether you are sending the correct, like the dictionary contains both of these keys and some values for it,
Yep.
strings.
And it seems to be resolved.
Okay,
Yep.
so if you are from the Python side, not from the Rust side, you will find that like why that question is valid. And if you are from a Rust developer, you will find that this guy is writing really strange bad code because he's directly calling unwrap. So when we are calling unwrap, we are at that moment we are kind of sure that this value exists for sure, or else panic. Because this is again a demo code, I'm just using this style. You can, if you were start learning Rust, you will find out that there are better ways of dealing with code where we want to make sure that the keys which we want exist or not. If not, we should actually throw back a different exception. Hey, we expected the key city in our dictionary, but it's not there. Maybe there is a country, but not city. So you have to write the code to make sure that you like handle those corner cases. And again, this is a straight and simple example. I think 4 lines of code inside of the function. That's why I wrote it in this way.
Yeah.
But
So so one comment is that it would be interesting to see how you correctly handle incorrect data.
correctly handle incorrect status. I can start right trying to. I can try to write more Rust code right now, and I'm trying not to do it because then we'll get into more of Rust side than stay on a Python workshop.
Yeah.
So I can show you
I
something else.
guess you can take this as an example in the future, I guess.
Yeah, so I'll show you in something instead. So just in the like in your browser, search for Rust book. The Rust programming language book. Press S to search in this book and search about unwrap. And the first answer, error handling, recoverable errors with result. Let's go this. And you can see that the person who saw that particular error, which is related to unwrap, the panic, you will find it here. Like how and like what happens when we call unwrap, how to deal with it. One maybe a way of panic, like with a expect, or we can propagate the error up. That means we can actually throw back an error from the Rust code, maybe to the Python land, saying, hey, this key doesn't exist. Let me have a look at something else. And maybe I can search here. And you can search or in the book itself. let's now maybe here Rust hash map. So that particular error came from the hash map. So we'll go check the documentation. And in the left hand side, it shows all the different methods. There is something called contents key. And you can see it checks for if the key is there or not.
Yep. So Jen said, excellent. Thank you for the pointers, and he will definitely check it out after the workshop.
Okay, so we still have 30 minutes. So I'm just wondering if I try to write some Rust code or not. Maybe not. But what you should do is actually here you can check whether the key is actually there in the hash map or not. And if it is not there, if the function returns false, then you create a new exception and return it, saying that, hey, key missing or something, or important key missing, like call whatever you want to call that exception and return it at that moment. So if I go back to terminal, so that should be I guess if not data dot contents, what was the method? Contents key. Maybe city. While typing any kind of Rust code, I'm always kind of a little bit confused if I don't type Rust regularly. And then I have to create first another exception maybe here. Let's try. And the people, you may already notice that I'm trying to do live code, which is always a super bad idea at any moment. Let's call it missing error. So I have to first check how to create an exception, which is here. Go up. Now just type it. So at this moment, I'm sure that if the key is not there, it should return back an exception at this point. It should not go down up to the unwrap. And if it reaches on this line number 22, it should be okay. And let's see if I wrote a read statement correctly or not. I'm doing a build. I should have done a develop. But if there is an error, it should come up here. At least no errors. So I'll still do a macro in develop. Oops, typing mistake. Okay, no errors. So and 3 import random OS. Let's create a dictionary with keys we want. Maybe name is Python and will not pass city at all. There is no city. Let's try to send this across. Here, you can see now it says that the key missing error is exception is raised, and it says key city is missing. Maybe I typed, I'm not sure. I mean, I hope this is helpful for the person who asked for seeing an example, like how to handle this. I will go back to the source code. So we checked on the hash map whether the key is there or not, and then if it is missing, then we raised an exception. And to do so, we already added the exception. And I should have done one more thing, which is go down to the end and just added one more exception here so that you can actually export it. I mean, import it properly. It is key missing error. This should have been better. So adding one exception, then if the key is missing, we are raising the exception and also making sure to add it to the module level so that you can import it properly and deal with it later on. I hope this is the example you wanted to check. I'll wait for a minute or 30 seconds to see if there is any feedback on this. But please remember to check the documentation. And the Rust book is really nice, where you can go and check various examples also.
Yeah, so got a comment. So awesome, thanks.
Thank you. I'll say dot batch. I will add this example later on in a different branch, maybe. I'll go back to the ROS branch. Any questions related to ROS? ROS. So just like the sysinfo crate, you can actually use any other Rust mod crates here, and have hidden away. You can all the details from the Python side and only give access to the things you want. In this case, we have a method number of processors, which is giving out the exact details we need. If no questions, then we'll try to move into the next part, which is one small thing. Even though it's small, I like the first time I actually tried to do this workshop, I completely misread the documentation because I never tried it myself in any of my production code, which is how to add dunder methods, double underscore name, double underscore those. So those are there in a different branch called ROS underscore or ROS hyphen more. ROS hyphen more. Here, we have to add another block with a saying pyproto. This will add those special dunder methods. In this case, we are adding dunder repr and dunder str. And we are creating a string which says ROS and the number of CPUs. So when we try to print the particular variable, we'll see this in the text. So let's try this. First step is compile. Oh. Python 3, rather from random OS, import ROS are equal to ROS. And then if I just type R, You can see now it's printing a proper formatted text with saying the CPU's number is 8. So it's mentioned in the documentation, but I totally misread it last time I tried during a live workshop. So there is that. I believe with this particular example, if you do not have any questions, up to at this level, you should be ready to start writing your own Python modules in Rust, and you can add or start using various other libraries, or rather crates provided in the Rust ecosystem. Again, if I go back to the Firefox browser and maybe on the PyO3 documentation, so if I come down, there should be, yes, examples. So here are various examples, other Python modules which are written in Rust, so that you can go and check the source code to see like the kind of things you want to find out. If you have any queries, you can also reach out to me. This is my Twitter handle, and I regularly blog at kushaldas.in. So like you'll find my email address and other details there. I think I need to go to the screen. Yep, here. So if you have any queries, feel free to ask me on Twitter or reach out over email. And like today morning, actually, when I tweeted about this workshop, there was like a couple of other company, one particular company from Bangalore also asked if they are looking for Rust and Python developers who can write Python modules in Rust for some autonomous robots. So check out my Twitter thread about the job openings and things. I just heard about them today, so I don't know much. But otherwise, like if you have any queries at this moment about Rust, about Python, about other things, I'm wearing a Tor t-shirt, Tor project. You want to ask me about anything about Tor or anything else, feel free to ask.
Yep, seize the moment. So we have feedback from Halio. Great talk.
Oh, thank you.
Yeah.
I hope my video is increasing now.
Yep, it's getting bigger and bigger and bigger. So one question, which is not exactly related to
Go ahead,
this.
ask.
So when I look at this, right? So the way you are doing the wrapping is quite similar to Pipeline 11 for C++. So for someone who is already using Pipeline, so how would you raise the learning curve if they try to do the same thing for Rust?
Someone is doing what?
So someone who is already familiar with Pipeline 11,
Okay.
and they move to Rust, right? So how would you raise the difficulty or the learning curve in this
Okay.
transition?
That's an excellent question, and in my mind, that totally depends on the developer to developer. I found Rust very difficult at the beginning, not the language, but more about dealing with all the errors. Sorry. So, like the number of exceptions and the errors the compilers were telling me at the very beginning, I found it was difficult. But then slowly I started to figure out how to become a friend with the Rust compiler and understand those many lines of errors thrown on my screen. And at that moment, I found it was much easier for me to go ahead. And the community is amazing. Just like the Python community, they are also readily available to answer. Most of the Rust developers, you'll find the community on the Rust Discord. That's the easiest way to find answer. But if you are doing PyO3 development, like using PyO3, you can always go to the GitHub channel of PyO3 and find more answers there.
Yep. Great. So I guess since there are no more questions, I guess we can end here. So again, thank you very much for Kasha for this very interesting workshop, and the video will stay on YouTube forever. So if you at any point want to follow the steps again, so feel free to watch the video again and also check out the GitHub for the examples. So we are going to have a closing statement from Christine at 5 p.m. So remember to check out for the very important information. We also have feedback from Edwin. Thanks, it's an awesome workshop, very enjoyable.
Thank you once again.
Yeah.
Bye.
So thank you very much. Bye bye.